Okay, today we are going to start our lessons on the 6th grade readiness teaks. The teaks that we have here are provided by some free resources online. The first teak we're going to look at is 6.2D. It is a readiness teak in category 1, and it is about number relationships. You're going to have to be able to order a set of rational numbers. Rational can be fractions, could be decimals, could be positives, could be negatives, as they arise for mathematical and real-world contexts. Here are some of the vocabulary you can see in this teak. Today we're going to focus on, again, the word order. We're going to look to see if they want us to do it greatest to least or least to greatest. Don't let them trick us up on the simple stuff. And again, it's going to be just our rational numbers, those fractions, decimals, percents, positives or negatives. So here's our example problem. During 1 month, 4 trees at a nursery increased in height at the rates shown below: 8%, 1/12, 16%, and 1/20. At this point, I want you to go ahead and try this yourself. See if you can figure out how you would order these. Now in this situation, please notice it says which lists for the race are G to L, or greatest to least. Go ahead and take the time now to solve this. Okay, now here is how I would go about doing this problem. For me, it's easier to just take my fractions and either turn them into a percent, or to take your percents and change them into a fraction. Let's just go with percents because I know how to very quickly change 1/20 to become a percent out of 100. If I do times 5, that is a terrible looking 5. Let me try this again. Erase. Oh, and I can change colors. Let's do times 5 on the bottom. Whatever I do in the bottom of the fraction to keep it equivalent, I have to do on the top, which would be 5 out of 100. So 1/20 is really the same as 5%. Then I see we have 8% also. And it's going to come down to either the 1/12 or the 1/16. 12 doesn't go as easily into 100. It was very easy to go from 20 to 100 without any issues. With 12, we're going to have to divide. So let's put 1 in the house, or another way of thinking of it is if you draw a line up this way, it tells you which one is going into the house there. So the 12 is outside. Norman is in the house. 12 does not go into 1, so we're going to need the soccer ball. It's not wanting me to do a dot. There's my dot. And my 2 zeros. Kick that soccer ball through the roof. There's my decimal up top also. With dividing, you always line up your decimals. It does not go into 10, so we're going to put a 0 here. Now it's figuring out how many times 12 goes into 100. Well, I know 12 times 10 is 120. So if 12 times 10 equals 120, it's got to be less than that. So let's try maybe 12 times 8. 12 times 8. 8 times 2 is 16. 8 times 1 is 8. Plus that one more is 9. So we have 96. Oh, I'm coming off the screen here. Let's just put our 96 over here. That was 8 times. So let me switch colors so you can keep track. We're doing our subtracting. Borrow from the 1, making this a 10. Then we're going to borrow from the 10, making this a 9, and take 10 minus 6 is 4. 9 minus 9, 0. Bring down the 0. 12 into 40. I know 12 times 4 is 48, so I think we need 12 times 3. 3 times 2 is 6. 3 times 1 is 3. So we would have 36. I think that's as high as you can get it. That was 3 times. And we can stop because we're in the thousands place. We never really go past that thousands place. And then let's go ahead and count over. To change a decimal to a percent, we're going to use the Dr. Pepper technique. That's a D if you can't tell, and a P for pepper. You're going to hop 2 decimal places to the right because percent is always out of 100. You can also think of it this way. If I put a 1 below the decimal and fill in a 0, there's my hundreds place, and percent is always going to go to 100. So this is 8.3%. Now 8.3% is going to be slightly higher than 8%, but not quite as high as the 16%. So let me kind of clear out what we had. I think I can erase my ink. So this was 8.3%. Does not like my decimal points. And this one was 5%. So 5% was the smallest. Let's see which one. That's not showing it the smallest. That's not showing it the smallest. And the 16% was the biggest. 16% showing the biggest here. And to confirm, the 8.3 has got to be bigger. It is than just the 8%. So I've got an answer of C. All right. See if you want to go back and check your work. If you used any other techniques and we're still able to get the correct answer, awesome. I can't wait to hear about it in class. I want to see us using good Cornell notes to take notes about any questions you have, and I want to see how you work through this yourself, along with your solution. I want all of that recorded in your journal. So, the answer after all of this, why does it say B? What did I pick? Greatest to least. Oh, I did it backwards. I hate it when they get me. All right. This said greatest to least. I forgot the most important thing, so I eliminated my right answer. I should have done this is the greatest, this is the least. I completely reversed my answer. Oh, let's fix that. Was anybody panicking? I bet you were. All right, so B was our right answer. Awesome. So the answer is B. We converted all to the same form. We wanted to make sure that everything was the same form. That is a key to our discussion about this. I'm going to be asking you a quiz question there on that. Make sure you know that everything needs to be all fractions with common denominators or all percents so that they're easier to compare. One of our processing techniques we used was to analyze mathematical relationships to connect and communicate ideas. Thank you so much for your time. Again, I want to see all this recorded in your notes, and make sure that you've answered any questions along with this video.